So this video is going to be about our fourth type of equation that we'll be solving, and that is an absolute value equation. Our goal is to be able to solve an absolute value equation as well as an absolute value inequality, and then we're going to be graphing that on a number line when necessary. That's not always necessary. So first of all, let's talk about what absolute value looks like. So absolute value is the distance of a number from zero. So if you were standing at 0 and you wanted to move to the number 3, you would walk 3 steps. Or if you wanted to walk to the number -3, you would also walk 3 steps. It would just be in a different direction. So absolute value is basically the number of steps or hops or however you want to think about it on the number line that it takes you to get to your number. It doesn't matter which direction you're going. So the absolute value of 3 is simply 3 because it would take you 3 steps to get there if you're standing at 0. -3 is also 3 because you'd be going to the left, but you'd be taking 3 steps to get there. This helps us when we're solving because we have to think about both directions from 0 when we're solving. So this equation says that the absolute value of x minus 18 equals 5. What that means is that what's inside the absolute value could be equal to 5, or it could be equal to -5. Because we have two numbers that are 5 units from 0. So we have to set up two different equations in order to solve. We need to figure out what number minus 18 is equal to 5 and what number minus 18 is equal to -5, because both of those values will give us an absolute value of 5. Well, this is pretty easy math, right? We add 18 and we get 23, and we add 18 and we get 13. Which means that when x is 13 and we subtract 18 and take the absolute value of it, we're 5 units from 0. And when x is 23 and we subtract 18 and take the absolute value, we are still 5 units from 0. Let's try another one. We're going to set up two equations here. We're going to say that m plus 6 is equal to 2. And we're going to say that m plus 6 is equal to -2. So I'm just taking what's inside the absolute value and I'm setting it equal to both positive and negative of the other side. That was not grammatically correct, but I hope you understand what I mean by that. And then we just solve. So we're going to subtract 6 for this one. And 2 minus 6 is, of course, equal to -4. And then we're going to subtract 6 over here, and we get -2 minus 6, which is equal to -8. So if I put in -8 or -4 into this equation, I'm going to get an absolute value of 2. All right, so we're going to get a little more complicated here. What happens with this 9? I have a 9 outside. So before we can set up our two equations, we want to get the absolute value by itself. So I'm going to subtract 9 to the other side. So now I have the absolute value of 5x minus 6 is equal to -9. Let's think about this for a second. Can something be a -9 units from 0? Well, we said absolute value is how many steps you take, and you can't take -9 steps. That'd be like taking steps away from yourself, which is not possible. And so we can't solve this because there's no value of x that when we plug it into this equation is going to be -9 units, or not -9 steps is a better way to say that, sorry, from 0. So there's no solution here, okay? Note to yourself, absolute value, I'm going to write this down so you can see it. Absolute value can never be equal to a negative. Never. Never, 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 okay? You cannot go negative steps from 0. Negative has to do with direction and not with magnitude, just to throw some despicable me vector at you there. Our crimes here only have magnitude. They do not have direction. So we are only talking about how many steps am I taking from 0. It doesn't matter which direction I'm going, okay? So the other thing we need to talk about are absolute values and what happens when we get what's called an extraneous solution. So an extraneous solution is a solution that even though you did all of your steps right, it doesn't satisfy the equation. And a lot of times this has to do with that negative piece of it. So it's really important to always check your answers just to make sure that they're not extraneous, okay? And we didn't do that on the last one, but let's go back and just check it. So let's just pick, let's say we solved this, okay? Here, how about this? So let's say we solved this. We said 5x minus 6 equals negative 9. And then I'm going to add 6 to the negative 9, and I get negative 3, and I get x equals negative 3/5. If I plug negative 3/5 back into this original absolute value equation, I'm write this down. Okay, so I have the absolute value of 5 times negative 3/5 minus 6 plus 9 is going to be equal to 0. Well, 5 times negative 3/5 is negative 3, minus 6 is negative 9, and the absolute value of negative 9 is 9. 9 plus 9 does not, in any world, equal 0. It equals 18. So this would be an extraneous solution. The math is good. We solved correctly. I didn't make any mistakes here or mess up a negative or anything. I did all the math correctly, but it doesn't satisfy the original equation. And that, of course, is because the original equation has no solution that will work for x. So when we're solving, we always want to check our answers just to make sure that they do, in fact, create a true statement from the original. So let's look at this one. We're going to set up our two equations again. So we're going to say 2x plus 12 is equal to 4x, and 2x plus 12 is equal to negative 4x. And then we're just going to solve these. So I'm going to combine the x's. I'm going to subtract 2x, and I'm going to divide by 2, and I get x is equal to 6. Over on the right side, I'm going to do the same process again. So I'm going to subtract the 2x, and I'm going to get negative 6x is equal to 12. Divide by negative 6, and I get x is equal to negative 2. Now, if I put these back in to check, let's start with 6. So I'm going to say 2 times 6 plus 12, absolute value, should equal 4 times 6. Well, 2 times 6 is 12, and 12 plus 12 is 24. And the absolute value of 24 is 24. And 4 times 6 is 24. So that's valid. 6 makes that a true statement. Now let me plug in negative 2. So 2 times negative 2 plus 12, absolute value, is going to be equal to 4 times negative 2. 2 times negative 2 is negative 4 plus 12 is 8, and the absolute value of 8 is 8. 4 times negative 2 is negative 8. 8 does not equal negative 8. That is not true. This negative 2 is an extraneous solution. So the only valid answer here is x equals 6, not x equals negative 2. And you'll see that sometimes, I don't want to say a lot, but sometimes with an absolute value equation, you'll see where one solution makes it true and one solution does not. Now, I do not want you to make any assumptions that it's because 6 is positive and 2 is negative. That is not true. It just so happens to work out that way this one time. Because we checked our answers, and the negative 2 is the extraneous one that makes the original equation false. So always check your answers, okay? Moral of that story. So the second thing we need to talk about is an absolute value inequality. And we set this up as a compound inequality, meaning we're going to have 2, okay? So if we're looking at the statement, the absolute value of A is less than 4. That means that every solution will be less than 4 units from 0 on the number line, less than 4 steps away. So 2, 3, here's 4, meaning that I'm considering everything in this area here between 0 and 4. But I'm also considering everything between 0 and negative 4, because that is also less than 4 units or 4 steps from 0 on the number line, okay? So let's talk about what this looks like when we set up an equation. We're going to rewrite a less than as an and statement. So I'm going to say that 2x minus 2 is less than or equal to 4. And I'm just going to write it this way for right now, and then I'll show you. 2x minus 2 is greater than or equal to negative 4. So do you see what I did there? I changed the sign, just like we did on the first ones, and I flipped the inequality sign. Now, we can put this together as a compound because 2x minus 2 is less than 4, and it's greater than or equal to negative 4. So I can put those all together as one and then just solve it as a compound inequality. However, to be honest, if you write it as an and statement and keep it separate, that's fine too. So let's solve this. I'm going to add 2 to both sides. So over here now I have -2 is less than or equal to 2x is less than or equal to 6. And then I'm going to divide by 2, and I get -1 is less than or equal to x is less than or equal to 3. There's my compound inequality. And then if I were to graph this, of course, on a number line, let's see, let's put 0 here, 1, 2, 3, 1, 2, 3. I'm going to have a closed circle at -1 and a closed circle at 3. And because it's an and, I'm going to connect between them. So I've got this graphed on a number line, okay? The other one we need to talk about is what about when it's a greater than? So here we have an absolute value of A is greater than 4, means that we're looking at everything that's more than 4 units from 0. Well, 1, 2, 3, 4. That means that it's everything out here, right? 5, 6, 7, 10.3, 100.92, as well as everything that is farther than -4, -5, -6, -99.7, whatever, okay? Now you've seen this before. This is an or statement. So when we do an absolute value where it's greater than, we're going to rewrite it as an or statement. So this one, for example, we're going to say 3x minus 12 is greater than or equal to 6, or 3x minus 12 is less than or equal to -6. So do you see what I'm doing? Every time I'm changing the positive and negative, and I'm flipping the inequality sign. You have to do both parts there in order to make this valid, okay? And it's an or statement, so I don't have to combine it like I did the compound. And I'm just going to solve each one. So I'm going to start by adding 12, and 6 plus 12 is 18. And then I'm going to divide by 3, and I get x is greater than or equal to 6. I had to think about my math there for a second. Or I'm going to come over here on the right side, and I'm going to do the same process. So I'm going to add 12. -6 plus 12 is 6. And I'm going to divide by 3. And I get x is less than or equal to 2. So here is my compound inequality. X is greater than or equal to 6, or x is less than or equal to 2. I can graph that if I really want to on a number line. And then let's see, 0, 1, 2, 3, 4, 5, 6. I would have a closed circle on 6 going to the right and a closed circle on 2 going to the left. And there I've got my or statement. Okay, so let's try one. This is probably a good time if you want to pause the video and see if you can set up the 2 equations here, or the 2 inequalities, I apologize. But they're going to look like 2x minus 7 is greater than 1, or 2x minus 7 is less than -1. Now, how did I know that was an or statement? Because the original is a greater than, which is always an or statement. But it also kind of makes sense. It's greater than 1 or less than -1 because we can't have an and. We don't have a number that is greater than 1 as well as less than -1. There's nothing that fits that. That's how I know that it's an or statement. So I kind of just think in my head, do I have a number that fits both of these? It's an and, or if I don't, then it's an or. Okay, I'm going to solve them. So I'm going to start by adding 7, and I get 2x is greater than 8, divide by 2, and x is greater than 4. Or, then I'm going to come over here, I'm going to add 7, so 2x is less than 6, divide by 2, and x is less than 3. Here I have my inequality, x is greater than 4, or x is less than 3. Let's try another one. Again, pause the video, try this one on your own, see how far you get, and then compare. So we're going to set up our 2 equations here. 3x plus 5 is less than 10 and greater than -10. Again, I knew this was a compound inequality, and I knew it was going to be an and because of the less than. I'm going to solve simultaneously, so I'm going to subtract 5 from both sides, which gives me -15 is less than 3x is less than 5. And then I'm going to divide by 3. And I get -5 is less than x is less than 5/3. There is my compound inequality. I'm not going to graph it on a number line this time, but you certainly could if you wanted to, or if you were asked to do so. Okay? So hopefully you're feeling like you can solve an absolute value equation and you can set up the two different ones. And then I hope you are feeling as confident as well about solving an absolute value inequality and knowing that a less than means an and a greater than means an or. I hope that you are feeling confident about your absolute value as a whole, how to solve both the equations and inequalities. Best of luck with your solving.